Okay, I don't want to take a ton of time on this. We do have a win exit ticket again today. But this is radical and exponent notation. And I don't expect to have this on the test. I'll have to go back to see what I did last year. But it shouldn't be, it shouldn't be earth-shattering to remember. I can see where it'd be hard to remember which is which, but you're just going to have to figure out a way to memorize it. And what I mean by that is if you have exponents that are a fraction, you make them as a radical, the denominator is always the index number and the numerator stays as your exponent. That's the part that a lot of students get switched around. But other than that, it's just a memorization thing. If you have an exponent, this number is the base number. That base number still stays. I don't know if it's called the base in the radical, but that still stays as kind of the main number. And then you can do this either way. Since it says or, if we're being honest, I usually write my answer this way, but if I actually have to do math, I usually do it this way. We'll talk about that later today. And then vice versa. I also do radical form backwards and put it into exponent form. But again, don't expect to have this on the test. I don't think that I gave it to people last year, but honestly, I'll probably just do whatever I did last year if I can figure out specifically what that is. So if you follow that map, and again, if you do all the notes today, and if you do your worksheet today, most of you guys will kind of have that memorized by accident. You won't actually have to like sit and study. So in simplified radical notation, so the first one, again, I put A as my base number with my radical, and then the denominator goes in front, the exponent goes either there or could go outside if you want to use parentheses. But remember, an exponent of 1, you don't actually have to put, so that ends up being the 8th root of A. When I used to teach this, they had a separate formula if there was a 1 in the numerator, but the thing is, it was the exact same formula, and so I just stopped teaching it that way. So if you want to memorize that A to the 1/8 is just the 8th root of A, that's fine, but you can also just follow that formula. And if you put this in your as an answer, I'm okay with that. Like if you leave the exponent of 1, it's not necessarily like the cleanest, most beautiful looking answer, but that's okay. The next one, x to the 1/4 is the 4th root of x. Again, technically it's the 4th root of x to the first power. Y to the 1/3 is the 3rd root of y, and t to the 1/2 is the square root of t. Again, if you want to put the 2 there, you can. If you want to put the 1 there, you're more than welcome to. But in that one, you don't need either of those. Nice, and your calculators are a little different, but with my old graphic calculator, if I want to put in the 4th root of a number, I have to go to like 3 different menus, and it's just easier to put 215 raised to the 1/4 power. So that's another thing you can use. I'm going to skip the you do problems for this because I'm going to go straight into these. Maybe I should make this shorter. Anyway. Something other than 2 in the numerator, but again, it's the same exact formula. That's the reason why it's called 1. You do the same thing. I start off with putting my base number with the radical, then the denominator goes in the numerator, the denominator goes as the exponent, the numerator stays, oh geez. The denominator is the index number. I'm saying the wrong thing. I wrote the right thing. And the numerator stays as an exponent. Now, if you have one like number 9, they throw a little bit of a wrench into it. It looks more complicated, but really the only thing that makes it more complicated is you have to remember your exponent property that says if you have an exponent raised to another exponent, you multiply those. So x to the 3rd to the 1/6, you can multiply your exponents. If you need to use a calculator, you can, but remember with fractions, you just multiply straight across. 3 times 1, 6 times 1. So this is x raised to the 3/6. Make sure you reduce that fraction before you do anything. That's x to the 1/2. So your final answer for this one is the square root of x. Or again, if you put the index number of 2, that's fine. Make sure you're reducing your fractions with that. Technically, I'm assuming there's a way you can reduce those if you use your head. Once you have them in radical form, I'm sure you can reduce them, but I think that's way more difficult, in my opinion. Same thing with this next one. We multiply our exponents, so that is n to the 2 over 6. 2 over 6 is 1/3, so this is the same thing as the third root of n to the first, or the third root of n. Again, there's that same formula every single time. Your denominator is your index number, your numerator stays as the exponent. Now, number 11, they try to put a little twist into this by giving you the square root. Again, I'm sure there's other ways to do this, but I would do it where I convert it into an exponent first. Now you can multiply 1/2 by 1/4 is 1/8. And now you can put that into radical form. Again, I'm sure there's other ways to do that one, but I think that's, in my opinion, that's going to be the easiest way. At least it's the most consistent because it's the same way we've done all those. All right, go ahead and do those next 3 on your own. I'll give you guys a minute, 2 minutes-ish, and then we'll keep trucking. All right, my answers are up there, 12, 13, 14. Again, there is a little bit of math in there where we multiply. It goes multiplying fractions. Your calculators do fractions a lot of times, but a lot of it's following that map, which if you're struggling, again, it just means you need more practice. Because once you get the pattern and once you get that memorized, these shouldn't take too long. Sorry, number 14 was over there. Okay. Now we're doing the opposite. So again, the instructions say write as a simplified exponent notation. Again, now same formula or that same map. I think I'd probably call it a map more than a formula. We're using the same thing. We're just moving backwards. I give you the radical. You need to move backwards into the exponent. So for this one, to the 1 over 7. The next one is x to the 4 over 7. Again, your index number is your denominator. This one is c. Again, the index number is your denominator. So this is just the other way to write that. Remember, if you look at our formula, we can also write it this way. That's the one we just did. That's how it was written. And lastly, make sure when you get your fraction, make sure you're reducing your fraction. So for this one, we end up getting y to the 6 over 2, which is y to the 3rd. If it helps you guys at all, I don't think, like I said, I'm not thinking that I'm going to give you this formula, but one way that I always memorize this formula, and maybe it's just more common because I have done this, obviously, for several years of my life, but I just know that the square root of x is the same thing as x to the 1/2. If you can remember that, then for me, it helps me kind of know, well, if it's a square root, the index is a 2, so that kind of helps you figure out that map. Maybe that doesn't help at all. Maybe that's, again, maybe that's something that's just common knowledge for me because I've done it so often. Again, I'm going to have you guys do the next 4 problems on your own. I'm not going to give you a ton of time. It shouldn't take you a ton of time, but I think doing some of these and getting into that rhythm, I think, will help. All right, so you're up there. Again, things that if you're struggling at all, you need to ask. There wasn't like, I mean, I would love to tell you guys to show me your work, but there's really no work to show. It's just doing that math. So make sure you know that. I hesitate to say these are easy because I don't want to make you feel bad. But if you're confused, they are ones you need to ask about. I guess basically, I think I said earlier in the year. I wouldn't say these are easy, but I know every one of you guys can understand this. So if you are lost, it's something I'm doing wrong, and you need to let me know so we can figure it out. Because there are people struggling with this. I'm sure there are. But if you speak up, I think we can iron it out. I think we can figure it out. This is definitely one of those that, I mean, I very much usually think you can do all the problems we do, but this is very much, I firmly believe that. Are there any questions, that said, over this before we go on? Okay. I guess I should say, I'm not going to say these are easy, but relative to all the other stuff we've done and imaginary numbers and quadratic formulas and all that, this should be better than that. Okay, so moving on to the next, where we are simplifying these. Now we actually have a number that's in there. And I'm going to try really hard. I actually went through and changed some. If I'm doing notation stuff where I want you to write it in exponent notation or radical notation, if I want you to go back and forth, I'm going to try to just have a variable in there and not a number, because I think that gets a little bit confusing. Whereas these problems, I'm not talking about going from one notation to another. I just want you to simplify it. Those are the ones I am going to give you a number and variable, and we'll simplify both. Now, before I do this, I will tell you on this. Again, I am fully aware that your calculator can do a lot of this work for you. You need to make sure you can show me your work, because again, I don't want you to be that guy, but I want you to know the process. I need that from you guys. I know the calculator on my phone when I talk. I get that, but a lot of people, when they whip out that calculator, they don't turn it to the side and get the scientific version, or they don't download the Desmos app or something. So if you're going to use a normal 4-function calculator, know some of this stuff. I said 144 raised to the 3 over 2. So the first thing I would do is I would put any of them, I would put in a radical notation. The ones I give you, obviously, if you look at all of them, they're all in exponent notation. So my first step, I'm going to put that into radical notation. So we have the square root of 144 to the 3rd. Now this is where I mentioned this earlier, write it just because that's a little quicker. You don't need parentheses. And if you want to write it that way, you can. That's how I'm going to leave it. But when I actually do this math, it actually, in my opinion, my word of wisdom, I would do it the other way instead. I would do the square root of 144 first, and then I would take that answer to the 3rd. Now again, I first even know that's the way I do my math, so it's up to you. Technically, you don't need the 2 there, the index number, because it's a square root. So, again, from here, what I would do first is the square root of 144 is 12. So we did the square root of 144, but we still did it with that 3rd power. 12 to the 3rd. You can use your exponent sheet if you want to. That should have 12 on there to the 3rd. You will get that on a test, a brand new copy. 1,700. Not too bad, hopefully. If you're somebody that's, okay, well, how do I do the square root? The good news is with the calculator, even without the calculator, but especially with the calculator, you don't have to do that one first. You could do, I'm supposed to do that. The other way, you could do 144 to the 3rd, and that's just going to be a lot bigger of a number. Is 2985984, and then take the square root of that. And if you actually do that in your calculator, that's the same answer we got. So the good news with this is it doesn't actually matter which order you go. Exponents and radicals are kind of the same thing. Doing the radical first, getting that number smaller before you make it bigger, I think is easier. Because the other option, you make that number a lot bigger, and then you make it a little bit smaller. But either way, it's fine. The big thing is show your work. And when I say show your work, that's the 2 steps I would show are those 2. I would do this one first, make it in radical form, and then I would do the radical first. Those are the 2 steps I would show. Then you'll have problems like number 24, where it's 4 to the 3rd raised to the 5 over 3. Again, I need you to show your work on this because I'm fully aware you guys could do 4 to the 3rd in your calculator and then do it that way. Honestly, if you want to do that, I guess that wouldn't be the end of the world as long as you show your work. Didn't think about that. But the way I would do, multiply those together like we were doing before. That's 4 to the 15 over 3. 15 over 3 is 5, so that's just 4 to the 5th. That's 1,024. Again, the other way you could have done it is you could have done 4 to the third is 64. And then said it's the third root of 64 to the fifth. Taking the third root of 64, that's 4, and then 4 to the fifth is 1024. So you could have done that way as well. Again, as long as you're showing me your work as much as you can, that's fine. And if you're somebody that's like, well, but I can just do it in my head, well, then show me what you're doing in your head. Because I have had very many students that are very bright, and they always manage to show me their work. Again, moving on to the next one. If you try to do the third root of 9, it doesn't actually work very well. But again, for me, I would do 9 to the 3 over 6. That'd be 9 to the 1. Oh, sorry. 6 over 3. I was going to say, that doesn't work at all. So I guess that's a good example where I don't think this stuff is really that hard. But again, if you're trying to do two things at once, if you're going too quickly, if you're not really paying attention, I don't think it's that hard, but it's also not that hard to mess up. We'll act like I did that on purpose for my self-esteem. 6 over 3 is 2, so 9 squared is just 81. So that's a problem that you could have not done with a calculator. And again, I'm not actually going to spring this on you, but I'm always tempted to give you this test where part of it you can't use a calculator on, and then give you questions like that, where really, as long as you know 9 squared, maybe next year. I always battle with that one. Is that it over there? Okay. Moving on to 26. Now we have two separate parts. We have the number 729 and the exponent, or your variable a to the 18. Or I guess I should say that's how I would look at it, two separate parts. And the reason is because when you have this exponent out front, or sorry, this exponent outside the parentheses, that goes to both the 729 and the a to the 18. That's one of those exponent properties you guys should remember, or you should have done from Algebra 1. I'm not saying you should actually remember it. You should have seen it before. So that is 729 to the 16, and a to the 18 to the 16. Once you have that, you simplify both of those. 729 to the 16, root of 729. You can use your calculator if you need to, or you can use the exponent list. Doesn't make any difference. That's why. Hold on. Hit the wrong button. So that ends up reducing down to 3. Exponent, your variable, this should be, in my opinion. Again, not like that it's actually super easy, but easier than what we did. I multiply my exponents together, so that's 18 over 6, and then whatever that fraction is, you reduce that. So 18 over 6 reduces really nicely down to a to the third, and that's really cute. So 3a to the third. Now on a test or a quiz, I'm going to ask that question rather than the ones we did, where there's no variables, because again, at least you can do the variable in your calculator. But again, that's why I need to see some of this stuff written down for your work. We'll do that when we do the 729 calculator and then by hand. And I think that since they have stuff written down, that's work. There's specific things I'm looking for. And then same thing with number 27, that's 36 raised to the 3 over 2, and x to the 6th raised to the 3 over 2. So this is the square root of 36. Square root of 36 is 6. 6 to the third. 216. Again, you can use your calculator or your exponent. That'll be on. Multiply these together. 18 over 2, so that is x to the 9th. And again, those are your answer. 216, x to the 9th is what that all reduces down to. And again, I need to see these steps. Check your work using a calculator, that's fine. If you put the answer down and then go back and put your work, I don't care how you do it, but I need to see those steps. I'm going to go ahead and say I'm going to do 31 and 32. If you want to do those on your own, if you feel like you're comfortable with this and you want to start your exit ticket, that's up to you. But I will put those answers up here in a second.